Hi everyone, welcome back. In this video, we are going to study the sum to infinity. Sum to infinity. That is, we are going to write like this: S infinity. Sum to infinity. What is that sum to infinity? It happens only in those geometric series with a common ratio is in between -1 and +1. That is common ratio. R must be in between -1 and +1. Okay, this is the main point. And this type of series is known as convergent series. It is convergent series. Okay, so when you add all the terms, sum to infinity means when you are adding all the terms. When you add all the terms, that is infinite number of terms. Answer will not be infinity or minus infinity. Don't expect the answer will become infinity or minus infinity, like infinity or minus infinity. Then what do you get? It is not infinity or minus infinity, and answer will be always you get answer a real number. Okay, don't expect a minus infinity or plus infinity because you are adding all the terms. Okay, all the terms, infinite number of terms, and don't expect the answer infinity or minus infinity. You will get a real number. Why it is so? Because after a particular number of terms, the rest of the terms are almost equal to 0. It is 0, okay? So when you add it, you are adding only zeros. So it's not going to give any impact on the answer. Is it clear? All right, I will show you an example. That is, look at this geometric series. 8 plus 4 plus 2 plus 1 plus 1 over 2, 1 over 4 plus 1 over 8 plus etc. Look at this series. You can see the numbers, the terms are getting smaller and smaller, isn't it? And look at the common ratio. R is equal to second term, that is 4 divided by 8, because I am taking this 2. So what is the answer? 1 over 2. Is it following this condition? Is it in between -1 and +1? Yes. So which means this series is known as convergent series. Okay. So when you add all these terms, you will get a particular number. And here the formula is S sum of infinite terms, not n, infinite. Infinity means t1 plus t2 plus t3 plus etc. The last number is t infinity. Okay, or we can represent by using sigma notation. Sigma n is equal to 1 to infinity tn. Is also same as this one. Okay, the top part is infinity because you are adding infinite number of all uncountable numbers, but there will be an answer, and we are using a simplest formula. That formula I will write it here. S infinity is equal to a divided by 1 minus r. This is the formula. Very simple formula. A divided by 1 minus r. I will show you its derivation in the class. Okay. So for the time being, just you need to know this formula. S infinity is equal to a divided by 1 minus r. Now just try this formula in this question. Okay. What is that question? 8 plus 4 plus 2 plus 1 etc, isn't it? Where a is equal to, what is a here? A is 8, first term, and common ratio already we found half. Then substitute S infinity is equal to 8 divided by 1 minus half. When you do this one, 8 divided by 1 minus half is half. When you do, 16 is the answer. You see that? 16. So when you add all the terms, t1, t2, t3, that is 8 plus 4 plus 2 plus 1 plus 1 over 2, 1 over 4, 1 over 8 plus 1 over 16, 1 over 32. All the terms, when you add it, the sum will be 16. So that series converge to a number. That is why its name is convergent series. You won't get any number, anything more than 16. I will show you. Okay, I will show you this with a finite number. For example, very same series, I'm just taking only first 10 terms. That is sum of 10 terms. Because 10 is a finite number, you can't use this formula. I will use the original formula. What is that? A r to the power n minus 1 divided by r minus 1. Substitute. What is a? 8. R is half to the power 10 minus 1 divided by half minus 1. When you use calculator, you will get the answer 15,98. See, almost close to 16. But here I used only 10 terms. Did you see that one? Answer is close to 16, right? Okay, very same. I'm going to use 100 terms, sum of 100 terms. Use the calculator. That is same formula, 8 half to the power 100 minus 1, because you already previous video you know this formula for a geometric series, isn't it? Okay, for finite numbers are added, we are using infinite number. This is the formula. This is the only formula that we are using. Okay, finite number, you are adding finite number of terms. If you add only this formula, you have to use, whether it is convergent or not, divided by half minus 1. When you use this one, you will get the answer 16 on the dot. You see that one? Okay, then if you try with the sum of 1000 terms, that is a r is half to the power 1000. 1000 minus 1 divided by half minus 1. When you do it in the calculator, again it will give you 16, which means 10,000, it's going to 1 million terms or 1 billion or 1 trillion terms. When you add it, it will give you the same answer, 16, which means sum to infinity will give you what? 16. You understand? Because after a particular number of terms, you will see only zeros. That's the reason why. So here the main point is common ratio is in between minus 1 and plus 1. Then only these things will work. Is it clear? All right, now we can do the examples. Example number 1, find the sum to infinity of the geometric series. Sigma n is equal to 1 to infinity 1 over 5 to the power n. Okay, let's try. You need to know what is a and what is r, isn't it? We already said that geometric series. So let me expand the first 3 terms and I need to know what is a and r. What is the first term? 1 over 5 to the power 1. First value of n is 1. The next term is 1 over 5 to the power 2. Next term is 1 over 5 to the power 3. It's going to go like that. So what is a? A is 1 over 5. And what is common ratio? Second term 1 over 5 squared divided by 1 over 5. It will give you 1 over 5. You can use the calculator. You will see that one. See, you can see that common ratio is in between minus 1 and plus 1. This is the main point. Then only these things will work. Okay, so I can find the sum to infinity. How do you find? What is the formula? A divided by 1 minus r. It's the simplest formula in this chapter. Okay, remember you are adding how many terms? Infinite number, all the terms, etc. 1 over 5 to the power 4, 1 over 5 to the power 5, etc. You will get the same answer. What is that answer? Okay, let me substitute and check. A is 1 over 5, 1 minus 1 over 5. When you do this one, answer will give you 1 over 4. Is clear? You can use the calculator, you will get 1 over 4. So this is the answer, 0,25. When you add all these terms, the answer will be converging to this number 1 over 4. Is it clear? Okay, let's go to the next question. Sum to infinity. Find sum to infinity of the following series. Okay, sum to infinity will work only in what? Geometric, only in geometric series with the common ratio between minus 1 and plus 1. Let me check where a is equal to 18 and the common ratio is, second term is negative 3 divided by 18. So the answer is negative 1 over 6. Is it clear? negative 1 over 6. Common ratio, we got it. So sum to infinity, what is the formula? S in, because this one is in between minus 1 and plus 1, is obviously, isn't it? It is obvious. So we can apply the formula. Sum to infinity is a divided by 1 minus r. It's going to be a is 18 divided by 1 minus r is minus 1 over 6. It is going to be 18 divided by 1 plus 1 over 6. When you do this one, answer will be 15,43. So we are done. So this is how we do this question. Go to the next example. Example number 3. It's a words problem, but the very same idea. A willow grows into a tree with a height of 2 meters in its first year. In the first year, its height will become 2 meters. Then what will happen? Its growth each year thereafter is 3 by 4 of its growth in the previous year. Okay, whatever is the growth in the previous year is going to be 3 by 4 is going to grow each year. That growth, okay? Then what is the greatest height it can reach? That's a question. So initially the height is 2. We can develop a geometric pattern. First height is what? 2 meter. Then the end of second year, it will be 3 by 4 of the previous one is what? 2. Is it clear? Then third year, again 3 by 4 of previous one is this one. That is 3 by 4 times 2. Isn't it? Okay, then next one is 3 by 4 of this one, previous one. That is 3 by 4 times 3 by 4 times 2. It's going to go like that. So let me arrange this one. 2 plus 3 by 4 times 2. This one is how many 3 by 4? That is 3 by 4 square, isn't it? Times 2. Then fourth year is going to be how many 3 by 4? 3 of them are there. That is 3 by 4 to the power 3 times 2 plus etc. See, we got a number series, okay? And what type of series is this one? Of course, this one is because the power is increasing. Here the power 1, here the power 2, power increasing means it's geometric pattern. Okay, so what is the common ratio here? Common ratio is second term, that is 2 times 3 by 4 divided by 2, first term. 2 to cancel is going to be 3 over 4. See, is it in between minus 1 and plus 1? Yes. That is minus 1 less than 3 by 4 less than 1. So it's a convergent series. So sum to infinity, what is the maximum height it can attain? Is sum to infinity, because every year 3 by 4th of the previous year's height is increasing, isn't it? So at the end it's going to reach a maximum height. What is that height? A divided by 1 minus r. So it's going to be a is 2 divided by 1 minus 3 by 4, isn't it? That is 2 divided by 1 over 4. So the answer is 8 meter. That tree will not grow more than 8 meter. So this is an application of what sum to infinity. Okay, it's a very important, this type of question also we can expect. All right, now we are moving to the last example, that is very important one. Okay, example number 4. For which values of x will the infinite geometric series converge? So it is sure that this one is a convergent series. Okay, so you have to find the value of x. How do you find the value of x? So we are making use of the main point. We know that it's a convergent series means its common ratio is in between minus 1 and plus 1. So just find out common ratio. Find the common ratio, then apply that one in that inequality and solve it. That's it. What is the common ratio here? Remember, this is a very important one. Second term 1 minus x to the power 2 divided by 1 minus x. Clear? How do you divide? Because the bases are same, which means powers you have to subtract because you are dividing. That is 1 minus x to the power 2 minus 1. this 2 minus this 1, isn't it? So 1 minus x to the power 1, that is 1 minus x is the answer. That is common, not the final answer, it's a common ratio, isn't it? Now what we are finding here, find the value of, we are looking for the value of x. So you have to place this one because this is surely an infinite, because it is given, which means common ratio. This is the formula, minus 1 less than r less than 1. That is minus 1 less than, what is r? 1 minus x less than 1. Now solve and find the value of x. How do you solve it? Because here two inequalities are there. So when you send a number, you have to send to both sides, okay? So you have to send a 1 to this side and this side. So 1 is going to be minus, isn't it? Other side, that is minus 1 less than minus x less than 1 minus 1. Okay, that 1 will go both sides, become minus 1, right? That's it. So it's going to be what? Minus 1 is going to be minus 2 less than minus x less than 0. We are looking for not minus x, is x. So how do you get x from minus x? Divide all of them with the minus 1. Minus 1. Minus 1. So you have to do it both sides, okay? So it's going, because you are dividing with a negative number, I told you what happened, inequality will change. So it's going to be 2 greater than x greater than 0. Clear? Or we can write it in a proper way, because x is in between 0. Smallest number you have to write first. X 0 less than x less than 2 is the answer. So x must be in between 0 and 2. Is it clear? So this is how we have to do this question. Alright guys, now we move to the homework section. Just try this homework. Here 3 questions are there. Please try yourself. Now we are almost done with the theory part of this chapter. I hope you understood all the theory part videos. Now on, we will be discussing questions from the past question papers. Thank you.